Hello friends, today we are going to understand the chapter Ratio and Proportions. This is a very important chapter for your coming competitive examinations. Many questions could be solved easily if you know the basic concepts of the chapter Ratio and Proportions. So let us see what we are going to cover in this chapter. So we are going to have some basics of ratios, some proportions and continued proportion questions, some tricky questions on the ratios, as well as I'm going to give you some practice questions for your practice. Let us understand what is a ratio. So ratio is basically a term used to compare two things having the similar units. Or in mathematical terms, we could say when we need to compare two things, we used to say it in ratios as ratio of income of person A to income of person B. Or if we take two numbers as A and B, we could say that ratio is A is to B. Or if we take two numbers as an example as 2 and 3, we could say the two numbers are in the ratio as 2 is to 3. Now we could even divide two numbers in the ratio 2 is to 3 as some total value is given to us. We could say the first value is 2 by 5th and 5 is 2 plus 3, and second is 3 by 5th of the total value. Or we could even use some constant value to divide some number in the ratio 2 is to 3 as the first number we could say as 2x and the second number as 3x, and then we can add these two values to equate it to equal to the total value. Then take out the value of x and put in 2x and 3x to get the first part and the second part. So this is how we could divide some numbers into two ratios or compare two things in the ratio. Now we have what is a proportion. Starting with the different definitions, firstly we have the fourth proportion. So fourth proportion is said to be the fourth number having the same ratio with the third as second is having with the first. Or if we take the example of A, B, C, D, we could say A having the same ratio with B as C is having with D. Or we could say it as A by B equals to C by D. Here A is known as the first proportion, B as the second proportion, C as the third proportion, and D as the fourth proportion. Right? Similarly, we could define the third proportion. In third proportion, it is defined as the third number having the same ratio with the second as second is having with the first. Similarly, if we take the example as A, B and C, we could say A is to B as B is to C. Or we could say A by B as B by C. Here A is known as the first proportion, B as the second, here also B as second, and C as the third proportion. Right? Similarly, we could explain the mean proportion. The mean proportion is defined as the second number having the ratio with the first as second is having with the third. Or we could write it as A is to B is to C, or in mathematical terms A by B is equals to B by C, or B as in root of AC. Here A is known as the first, B as the second or the mean proportion, and C as the third proportion. Right? I hope the definitions are very clear to you. Let us now see some questions based on these definitions. The very basic question says, divide rupees 128 in the ratio 3 is to 5. Now explain to you in the definitions how to divide a total value in some two given ratios. So we have two methods. We are going to practice the both. We could say here the first part is 3 by 8 of the total, which is given to us as 128, and second part is 5 by 8 of the total, again given to us as 128. Now we can cancel out 128 with 8 as 16 and get the result as the first part as 48, and the second with 8 as 128 again and get this answer as 80. This is the first part of classification. Or we could even classify in the second method by using some constant value and saying that first part be 3x and the second part be 5x, and add up this to equate it equal to the total value given to us as 128. Or we could say this as 8x is equals to 128. Take out the value of x from here as 16 and then put in the value of 3x to get the first part as 3 times x or 3 times 16 as 48, and second part as 5 times x as 5 times 16 as 80. I hope the basics of dividing the two things is clear. Now you having questions on the next concepts which we studied in the definitions. This is using two ratios to make a continued proportion. We are given two ratios as P is to Q as 2 is to 3 and Q is to R as 6 is to 7. And it is asked what will be P is to Q is to R. Now we could solve this question if we could equate the value of Q in both the ratios. As in, we are given that P is to Q and Q is to R. If we could in any means try to equate this value of Q, we could get the desired result. Let us see how. Now we are given that 2 is to 3 as 6 is to 7. Now if we want to equate this value of 3 and 6, which is representing Q in both the ratios, we could very well multiply 3 with 2 to make it equal to 6. But if we are multiplying 3 with 2, I need to multiply 2 also with 2, because if we multiply ratio with the same number in the numerator and the denominator, the ratio does not get affected. So it becomes like 4 is to 6 as 6 is to 7. Now we could equate this 6 and get the desired result as 4 is to 6 is to 7. I hope it's clear how to make continued proportion by equating some values. Let us see another basic questions. The next question says, what is the fourth proportion to the three numbers as 8, 12 and 30? So explain you in the definitions how to write three numbers and take out the fourth proportion. Means if we take the fourth numbers to be as x, we could write this as 8 by 12 equals to 30 by x. Now we could cancel out the values to get the desired result. As 4 goes with 8 with 2, 4 also cancels 12 with 3, 2 cancels 30 with 15, and we get the value for x as 45, which is our desired result. Right. I hope it's clear. Let us see another question based on the definitions. Now this question is asking me about the mean proportion. That what is the mean proportion between 9 and 16? So I explained in the definitions. Here I need to assume the second value as the mean value as the x, and I could say 9 by x equals to x by 16. So we could say x square is equals to 9 times 16, or take out the value of x as root of 144, which gives me the desired result as x is equals to 12, which is the mean proportion between 9 and 16. I hope the definitions are clear with the medium of this Few examples. Let us proceed. Another concept which we have is about clubbing the geometry with ratios. That means if we have two similar figures, we could say that the ratio of perimeters is equal to the ratio of sides. As we have these two triangles in front of us, we could say that the perimeter of triangle A to the perimeter of triangle B is equal to the ratio of any side of A to the ratio of any side of B, but the corresponding sides. Means A plus B plus C upon P plus Q plus R is equals to A by P is equals to B by Q is equals to C by R. The first definition. Also, we could say the ratio of areas is equals to the ratio of sides square or the ratio of perimeter square. That means if I want to need to compare the ratio of area of triangle ABC upon area triangle PQR is equals to the square of these ratios. I hope these two definitions are clear. Now we can use these definitions in many questions. Let us see how questions could be made easier using this. Now let's see this question based on the formula of the two similar figures. Two squares have their sides in the ratio 2:3. What is the ratio of their areas? As we have now learned that ratio of areas of two similar figures is equals to ratio of sides square. So we could very well take out the answer as 2 by 3 whole square as 4 by 9. So see how this question becomes very easy by this concept. Let us see one more question based on the same formula. Here the question says two circles have their areas in the ratio 4:5. What is the ratio of their circumference? Now again we know that ratio of areas of two similar figures is equals to ratio of perimeter or circumference square. So we could say that ratio of perimeter is equals to the root of ratio of areas that means we get the answer as root of 4 by 5 which gives me the desired result as 2 by root 5. So we can see how the questions could be made easier with this concept. So we can see how the questions can be made easier with the help of these concepts. Let us have few more questions. Now this question says that in a class the ratio of number of tables to number of chairs is 5:4. The number of chairs should be increased by what percent to make it equal to the number of tables. So normally we will start thinking that we require the exact number of tables and the chairs to answer this question, but actually we don't, as the question is asking me the answer in terms of percentages. So here we could very well assume that let the number of tables be 5 and number of chairs B4. So to make chairs equal to tables, I need to increase one chair for every 4 chairs. So we could say that the desired result or the desired percentage increase in chairs is equals to 1 for every 4. That means the required percentage becomes 25%. So we see that the question is so similar and so easy. So we see that how a difficult question can also be made easier with this concept. Let us see one more question. This question says that in the class the ratio of number of tables to number of chairs is 5:4. The similar question to the previous one. But the question here asks the number of tables should be reduced by what percent to make it equal to the number of chairs. So as similar to the last question, we could assume that tables to be as 5 and chairs to be as 4. Now to make tables equal to chairs, we need to reduce to one table for every 5 tables. So here the desired percentage decrease in tables is equals to 1 for every 5. So percentage becomes 20%. Right? Let us see one more question. Here the question is saying that 738 is divided in 3 parts in the ratio 2:3:4. The sum of the first and second should be reduced by what percent to make it equal to the third number. So normally here the person will start dividing 738 in the ratio of 2:3:4 as the first part to be the 2/9 of the total, second is 3/9 of the total, and third to be the 4/9 of the total. But actually we don't require it because the question is again of percentage. So we could assume to be the first part as 2, second part as 3, and the third part as 4. Now we could very well say that the addition of first and second, which is 5, to make it equal to the 4. So it becomes similar to the last question where you want to reduce 5 by 1 to make it equal to 4. So here again the desired percentage decrease is equals to 1 by 5, which gives me the same answer as 20%. So students, we see how the questions could be made very easier if we know the basic concepts of ratio proportion. So this could be very helpful in your preparations. Now I have some practice questions for your practice. You could note down these questions and practice it. Question number 1. A sum of money is to be distributed among P, Q, R, S in the proportion of 4:3:2:1. If R gets rupees 500 more than S, what is Q's share? Question 2. The sum of 3 numbers is 88. If the ratio of the first to the second is 1:2 and the ratio of the second to third is 4:5, find the second number. The fourth proportion to 2.5, 4 and 7.5. Third proportion to 16 and 36. Mean proportion to 7 and 28. You could try out these questions, and the key to these questions is first question says answers as rupees 1500, second 32, third 12, fourth 81, and fifth as 14. So students, thank you so much and best of luck for your coming examinations.